Before we start talking about types of functions that involve complex numbers, let's talk about the difference between single-valued and multiple-valued function. Now, these two are functions and they differ on the possibility of our results or values. Now, if the value of a certain complex numbers corresponds to a single value for z together with the use of z, that means it's a single valued function. But if it corresponds to more than one value, to each value of z that you can think of, it's a multiple valued function. So that's the idea here. I'm going to come up with some uh, comparison. Let's say, for example, if our function, let's say w, which is equal to, let's say, z squared, okay? Of course, we can write this as f of z if you let f of z being your w, so z squared. This is an example of a function that is considered to be a single valued function. That is because for every z, okay, for every z that you can think of, your value or your value of your function is only squaring that, okay? So the squaring of the given z. So say for example, let's say z is equal to 1 minus 2i. So for your f of z, okay, you only have one possibility here. That's actually, say for example, that it's z squared here. So you will have 1 minus 2i squared, which is actually the square of binomial. You have 1, then you have here minus 4, or if you would like to, you can write it in this manner: 1 minus 2i times 1 minus 2i. So you will get here 1 times 1 is 1, minus 2i for the inner, minus 2i for the outer, and plus 4i squared, okay? Which will give you a result, 1 minus 4i, and you will have here, this one here. Take note that the square of I, being I is equal to negative 1, the square root of negative 1, so I squared is actually negative 1. So what happens here is that you will have here minus now 4, because that's 4 times negative 1, which will give you a result of negative 3 minus 4i. This is your f of z for z identified as 1 minus 2i. As you can see, it only has one possibility. Hence, for a situation like this, it's actually considered as a single valued function, because for every z, you only have one f of z result, or in this case, one value for w. But for this next example, let's say w is equal to the root, or z to the power of 1 half. That means your f of z is equal to z to the power of 1 half, or the square root of z, okay? This is an example of a multiple valued function. As you can remember, in one of our videos in the previous playlist, we were able to identify that for every complex number, we can get the square root of that, but there are two possibilities. Okay, there are two possibilities. Now, allow me to provide here another the example that we have shared. You may view the video for that in your own time, but if we have here example last time, you have actually the result for, or the value which corresponds to negative 15. Let's say that would be our z. Okay, our z is negative 15 minus 8i. Again, this is already discussed in one of our videos. We're able, if this is our z, the square root of that is actually identified. Again, you may want to review that video. There are two possibilities, negative 1 plus 4i, and you will have the result, let's use parentheses. The first result is negative 1 plus 4i, and the other one is 1 minus 4i. We also tried to verify this in those videos, and we're able to identify that they are really square roots of the given. Now, since there are two possible results here, that is why this function is considered to be a multiple valued function. These are just two examples for functions with complex numbers, and the identification or the comparison to them is that one of them is actually a single valued function, and the other is actually a multiple valued function. Later on, when we talk about types of functions which involve complex numbers, there are some definitions that includes, like, say for example, this is a single valued function, or this is a multiple valued function. So at least you were able to verify that if we talk about single valued function, it only has one possible result. But for multiple valued function, of course, from the name itself, it has more than one value for this, pertaining on every value of our z. Thank you very much for watching.